This is section 3-8, solve systems of equations algebraically. So what we're going to learn to do is do the same thing we were doing with systems of equations where we were solving them with a graph. In this case, we are going to solve them algebraically. And the process we're going to use to do this is what is called substitution. So you're going to want to put this concept in your notes. So here's example number 1. We're going to solve the system of equations algebraically of these two equations, y equals x minus 3 and y equals 2x. Well, if you think about that, we have two things both equal to y. So we can substitute one of these things, 2x, in for y in the first equation. And what we will then have is 2x equals x minus 3. And you can see that down here, but I will show you the algebra so that you can see it as we go through. So we have 2x equals x minus 3. So what we can do is subtract x from each side, and now we have x equals, this is a zero pair, negative 3. So if x equals negative 3, then we can go back to the original equation. Either one of them would be fine. We can write that y equals x, which is negative 3, minus 3. Or we could write y equals 2 times negative 3. And in either case, we're going to get y equals negative 6. Y equals negative 6. So x is negative 3 and y is negative 6. So our point would be negative 3 for x and negative 6 for y. That is the solution to our equation. Let's take a look down here, and that's exactly what we get. So that's exactly what we get right here. Now we could also graph those two equations. Well, we had, okay, so we can graph this by looking at the two equations. We had y equals x minus 3. We also had y equals 2x. So if we graph y equals x minus 3 first, we have a negative 3 intercept. And notice that we have an error here. The slope here is a negative 3 intercept, but the slope is 1 over 1. So it should be up 1 over 1. So we should be at that point right here. Up 1 over 1 puts us at this point here, and you can see that they are off ever so slightly with their graph. So let's move it down in this direction, and you will see that it ought to come through to right about here. So now if I draw my nice straight line through intercept of negative 3, we'll have a line there. And I'll show you why this is really important in just a minute. Next, we're going to graph y equals 2x. Well, we have an intercept here that doesn't show, but it's 0. So we have an intercept right here at 0, and we have a slope of 2. So we could go up 2 and to the right 1, or we can go down 2, left 1, down 2, left 1, down 2, left 1, and we end up at this point right here. And now we're going to draw, actually this is a proper line for that particular equation. And now you will notice that if we circle our intersection here, we are here. If we circle our intersection here, we are right here at the point negative 3, negative 6, which is what our solution was. Whereas now I'm going to remember that's our point right here. I'm going to erase this so that you can see that their original equation shows that the intersection is here, which of course you realize both from this and from a proper graphing, they had the solution in the incorrect spot. Please press pause and do letters A and B. Let's try another problem. In this case, we're being asked to solve the system of equations algebraically, and we have y equals 3x plus 8. Additionally, we have 8x plus 4y equals 12. So we have one of the equations right here, 8x plus 4y equals 12. And now we can take y, which is 3x plus 8, and insert it right here for y. So we're going to insert the 3x plus 8 in where the y was, and that's where this comes from. So we have 8x plus the quantity, I'm going to write this over here so that you can see where this came from, 4 times the quantity, 3x plus 8. That's this portion right here. Okay? So we're going to say 4 times 3x is 12x, and 4 times positive 8 is plus 32. And that's where we get 12x plus 32 is right here. And originally we had out in front the 8x. So we have 8x plus 12x plus 32 equals 12. I'm going to back up a little bit here and erase some so that we're a little clearer. So now we can take the 8x and the 12x, and because they're like terms, we can combine those two, and obviously 8x plus 12x is 20x, and we still had the plus 32 equals 12. So we can take a look at taking care of the addition of 32 next. The obvious way to do that is to subtract 32 from both sides. So we have 20x plus 32 minus 32. We have a 0 pair, so this disappears. So we now have 20x equals 12 minus 32 is a negative 20. Remember, the way to do this is to think of, we have a negative and a positive, so we take the difference. The difference between 32 and 12 is 20, and it is more negative than positive, so it becomes a negative 20. So we had 20x equals negative 20. So we're going to solve that, and obviously what we need to do is divide both sides by 20. It's right here. 20x divided by 20 is x, and negative 20 divided by positive 20 is negative 1. So we have a solution of x equals negative 1. So now we can replace x with negative 1 in this equation, y equals 3x plus 8, which is one of our original equations. So we have y equals 3x plus 8. We put in negative 1 for x, and we have y equals 3 times negative 1 plus 8. So negative 3 times negative 1 is negative 3, plus 8 equals positive 5. Again, we have two different signs here, so we find the difference, which is 5, and it's more positive than negative, so we have a positive 5. So our point becomes negative 1, positive 5, and right here is our final answer. Please press pause and do letters C and D. Okay, let's take a look at example number 3. A total of 75 cookies and cakes were donated for a bake sale to raise money for the football team. There were 4 times as many cookies donated as cakes. Write a system of equations to represent this situation. Draw a bar diagram, and then write the system. So we have x equaling cakes, and we have y equaling cookies. Well, it says that there were 4 times as many cookies as cakes. So if we use this to represent cakes, we must have 4 of those to represent the cookies. Now write a system of equations. Well, in the beginning it says there were 4 times as many cookies donated as cakes. So we've got y equals 4x. That's shown right here because this cake being x, we could consider this, and this equal to this, so we could call that x. So y equals 4x. Additionally, we are told that there were a total of 75 cookies and cakes. So if we take x plus y, all of the cookies plus all the cakes, that will equal 75. So we have those two equations, y equals 4x and x plus y equals 75, shown right here. Okay, now we're being asked in problem number 4 to solve that system of equations algebraically and then interpret the solution. Since y is equal to 4x, you can replace y with 4x. So our original equation we had, let me write these down up here so you see these, y equals 4x, and our second equation was x plus y equals 75. Okay, so here we have x plus y equals 75, but also we know that y equals 4x. So we can take the 4x literally and place it in here. So over here, take a look at it. We have x plus 4x. We're replacing the y with 4x equals 75. So obviously x plus 4x is 5x. So we have 5x equals 75. The next thing we are going to do is divide both sides by 5. 5x divided by 5 is x, and 75 divided by 5 is 15. So since x is 15, we can then say, because y equals 4x, we can put 15 in for x right here and say that y equals 4 times 15 and do the math, and we get y equals 60. We have x equals 15 and y equals 60. So this is the solution to our system of equations, but then it says to interpret that solution. So in order to interpret that solution, if you think about it, if you go back to your bar diagram, you showed that x equaled the cakes and that y equaled the cookies. So now if you literally look at your solutions for x, we are saying that we had 15 cakes. And if you look at your solution for y, we are saying we had 60 cookies donated. Please press pause and do letters E and F.